sort of a ugly looking coast. It's not what you think as the Caribbean beach. No, it's quite a lot of weeds and rocks in the sand.
Okay.
And it can be very gray and windy.
I think we should probably begin. There's people waiting now. So
Okay. Yeah.
all right. So we're very happy to have Professor Bo Yang from Swansea University. He's going to talk about imperfect information learning and endogenous persistence. As always, comments during the talk are welcome. So this will be for an hour. Comments during the talk are welcome, but they should be short. And then we have 10 minutes for more detailed discussions after the talk. So yeah, floor is yours.
Sorry, was that me?
So yeah, you can go ahead and start.
Yeah, okay.
Okay.
Yeah. Oh, great. Thanks very much for this, and thanks very much for inviting me. I'd like to spend the next hour to talk about our work in progress titled Imperfect Information Learning and Endogenous Persistence, co-authored with three other of my former colleagues, Sabosh, Paul, and Joe. The paper it's in a quite preliminary form, and if I'm honest, results are also quite preliminary, despite the paper being around for quite a while. So as I said, any comments, suggestions will be very welcome. Right. In this paper, we really aim to address the following critique of existing DSGE models. The first of which is that traditionally existing DSGE models assume rationality or rational expectations, or the solution algorithm of existing DSGE models assume rationality or rational expectation solutions. And also assumes that agents who are in the model have a set of perfect information. So in the sense that they observe all the state variables, including all the exogenous shock processes, both of which assumptions all seem to be very extreme at moments, because rationality assumes that agents are solving the models with model consistent expectations, meaning that they know everything about the model solutions when solving for the models under REs. The second critique that we hope to address in this paper is that again, existing DSGE paradigm assumes that agents are representative. So we people simply cannot model any distributive effects among the agents who may be heterogeneous, or different groups of agents in the model. And there's certainly no way of assuming any idiosyncratic shocks by individual groups of agents in the model. The third critique that we hope to discuss here is that, as you know, in its most basic, simple canonical form of NK models, business cycles are only driven by shocks, exogenous shocks. So there's little or no source for any persistence endogenously driven by the model itself. Basically, unless the shocks assumed to be the dynamic persistent behavior that we observe in the real world. As a result, canonical NK models have needed to complicate their canonical form to include more realistic features in our economy, such as you know, as a standard, inflation, inertial, in the aggregate supply, and habit formation persistence in the aggregate demand. So these are the current criticisms of DSGE models. There have been, of course, alternatives within and outside the RE paradigm. The first, I mean, as opposed to assuming information is perfect, still under RE paradigm, we assume that what we term as the informational consistency principle, in the sense that economic agents can only have an imperfect set of information, in the sense that they are not able to assume or observe all the state variables in the model. They are not able to observe the stochastic shocks in the model either, in the sense that they can only have the same imperfect information sets as the top government econometrician who estimate model. So in the sense that they can only have the so-called observables that econometricians use for estimation. This is obviously motivated by the understanding that in reality, agents may be at most as smart as a well-informed government statistician who observed the data, who published the data, and who estimates the model. The second alternative, now outside the RE paradigm, is simply replacing RE with learning mechanisms. The purpose, the aim of these learning models, the aim of this sort of behavioral learning models is to limit the cognitive skills for at least one or several groups of agents in the model, in the sense that agents can, instead of assuming being extremely rational, they form statistical or point or adaptive learning with some heuristic forecasting, simple forecasting rules. I also want to mention that our assumption of assuming imperfect information is also learning, because as I said, if agents have imperfect information, they do not observe the states of the economy, the full states of the economy. They would have to learn via the solution of the DSGE model. So they would have to use the Kalman filter as an econometrician would use for estimating, for evaluating the likelihoods. They would have to use the Kalman filter for Kalman updating when learning from observing the observed variables for updating for the states variables of the model in the process of filtering. So Kalman filter is also learning, and the novelty of this work is to incorporate the Kalman filter learning into the solution technique when solving for the DSGE model. As I said, there have been, I think, a lot of work that has been done on heterogeneous agents, namely the two-sector agent, two-agent NK, the tank model, or three-agent NK model, or in its most general form, a Hank framework heterogeneous agent NK model. In the sense that this allows some interactive activities through the market via the traditional, via the standard transmission mechanisms in the propagation of the shocks, or more directly through the networks among the different groups of the agents in the model. As you know, for the two tank model, or for the two-agent NK model, you would assume that the two groups of agents, one of which is Ricardian, the other of which is non-Ricardian rule of thumb consumers, whereas you can also find 3 agent NK models where the addition would be a wealth rule of thumb models who also have access to the bond market. And in the most general forms of the Hank framework, one can simply model an idiosyncratic shocks among the heterogeneity of the consumers. So in this sense, we, in this paper, the first contribution is to, as I said, replace RE expectations with what we term as internal rationality. Because as I said, a model consistent expectation such as rationality is an extremely strong assumption. I know there was reason for this to be put forward by Sings Lucas because of the famous understanding from Milton Friedman's that agents are forming their expectations by catching up with reality. But rationality is strong, especially when we consider newly adapted policies, in the sense that perhaps for the policies to be very new, the agents might not be as well informed as rationality assumes in order to consider to be informed with the model consistent expectations. If we don't assume that they can observe the whole model solutions. But on the other hand, if we relaxing too much RE may be problematic because this relaxing AE or departure from AE may result in an infinite number of non-RE formations, leading to the problem of the so-called wilderness of non-RE proposed by Sims. Again, on the other hand, if the rules, the learning rules are heuristic, then there might also be a problem, which is exactly the problem pointed out by the Lucas critique. Agents might fall well considerably short of having rational expectations, and such models, as you know, are extremely vulnerable to the Lucas critique, especially when when we consider policy scenarios. So the point is that if we want to consider alternatives, they should avoid the two extremes. On the one hand, should not be assuming model consistent expectations, which seems to be extreme. On the other hand, should not be heuristic, or should not fall into the problem of wilderness. Should not be arbitrary, and should acknowledge at least some sort of impact of model consistent forecast of your model. So hopefully our NK behavioral framework that we propose here can acknowledge these points and all the previous critiques of DSGE models in some way. So are there any questions so far? If I mean, because I don't face the audience, I don't really know what's behind the screen. So.
Well, I have a quick question. So adaptive expectations, the precursors to RE, if agents, let's say, over predicted a variable, then in the next period they would upgrade their forecasts, and in that sense the errors were correlated over time, and if they under predicted, then they adjusted it downwards. So in heuristic rules, is it true that the expectation on the errors are correlated, or are there heuristic rules where the expectations on errors and in forecasting are also set to zero? What is it? Do you have an answer to that?
If you stick to the simplest heuristic rules, which we call heuristic rules, then the answer is no. The focus errors may not be informative in terms of making future forecasts. And this is the good point, that exactly the reason why we will introduce later on the so-called reinforcement learning, in order to rule out any sort of a stupid behavior, and in order to precisely deal with the wildness issue, is that agents can learn from the past mistakes, and they can reinforce their learning at each period, so that the past errors will be informative in making future learnings, in the sense that we will assume that there is a fitness measure or attractiveness measure, or whatever you like to call this, that this will generate a probability that agents will choose in the next period to choose between whether they will be more rational or more adaptive. Mm-hmm. So yes, the question is that with the enforcement learning mechanism, there will be a mechanism to endogenize the choice between rationality and adaptiveness. Mm-hmm.
Okay, thanks.
Yeah. So basically in terms of the expectation rules, the most general form is that the expectations can be endogenized in the model, in the sense that agents do not only learn from the past mistakes, focus errors, but also they can learn from each other. So in the sense that when endogenized in the model, the rational agents can become adaptive agents and vice versa, depending on the cost of being rational and depending on how far away the focus errors are from the reality. But in its least general form, it would be the simple point adaptive expectations, where the expectation can only be depending on the coefficient for adaptiveness in the past. Well, I'll come on to that in a bit more details later. Okay. Now, just to have a quick look at the literature on the behavioral model. Obviously, it was put forward by Brock and Hommes in 30 years ago. More recently, estimated and by de Grove. Their work was based on, like our work, based on the canonical three equation linearized, the so-called Workhorse NK model. So it has only three equations, the textbook version, really. The three equations are the Euler equation or the IS model, the Phillips curve, and the rule, the monetary policy rule. The solution of the model is coming from linearizing the DSGE framework about as a standard zero growth, zero inflation steady state, a deterministic steady state, with the IS model output or in the Euler version consumption, which are the same because we assume there's no government expenditure. We don't assume capital either, as in the three equation model. So output depends on the rational expectation of the next period's outputs and the nominal interest rates, and the rational expectation about next period inflation with the Euler equation shock. Most people interpret this as the demand shock. And on the supply side of the economy, inflation again depends on future expected inflation rationally, and the output gap by the coefficient of the Phillips curve slope, where most people interpret this as the supply shock. And the monetary rule is standard Taylor rule with the monetary policy shock. Or alternatively, if there's a flexible price block of the economy where there's no nominal rigidity, there is a flexible price output, so that one can define as its convention the output gap in the monetary policy rule. As I said, A denotes the RE, in our case, under perfect information. So both of which, as I said, are extreme assumptions with RE. I've said those. So we can simply introduce demand persistence through habits in the demand side, and price indexation in the supply side of the economy. And for our purpose, we obviously deliberately leave them out because we want to minimize the so-called model mechanical driven persistence, because we want to attribute learning, or attribute persistence into our learning mechanisms. In our case, the learning mechanism will take two mechanisms, one of which is the behavioral learning, the other of which is Kalman learning by assuming imperfect information. And we hope that the two learning mechanisms are competing, and perhaps one of another are able to match each other as well as each other. So in other words, that Kalman learning can perhaps perform as well as the behavior learning and vice versa when observing the data. Can't remember. Right, sorry, yeah, the last bullet point. The only nominal friction in this model is it's as usual Calvo pricing contracts. Right, so basically the first step to build expectation is to consider replacing RE with, in the simplest form, a simple heuristic rules. We obviously will introduce heterogeneity into our model by assuming two types of agents with different forecasting rules. So there will be different types of agents who have different forecasting rules, and more importantly, there will be a group of agents who may be RE, and another group of agents which will rely on a forecasting rule. In addition to that, as I said, to avoid any stupid behavior in learning and to address precisely the wildness issue, we assume that there's only one reinforcement learning rule to enhance the simple forecasting rule, so that there is a random sort of a choice variable in the model, so that if the payoff or the attractiveness variable I was referring to, the payoff, if the payoff of taking a certain action is higher in the past, in the sense that the forecasting error is minimized, then it will be more likely for this action to be taken in the future. So this is sort of a reinforcing learning for the future periods, right? Which we will call reinforcement learning. The central distinction we want to make in this paper is to distinguish what is termed as Euler learning and what is termed as what we think is called internal rationality. The difference is simple. Under Euler learning, basically agents learn about their Euler equation, Euler decision. They would still know the minimum state variable form of the economy, of the model, the solution form. They would base their learning on their next period consumption decisions, in the sense that they know the learning is taking place in the already linearized form, because they know the solutions, and they know that they are identical. So they don't think that when forming their Euler learning decisions, they don't think there are heterogeneity in agents. They think they are all identical because they have already the linearized model. Basically, in mechanically, this is simply replacing rational expectation in the linearized model with an adaptive mechanism, really. And this, if we don't go back to the full nonlinear setup of the model, this lacks the proper micro foundation. So that this goes back to the Lucas critique, that departure from rationality is really only a modest one. So in the sense that if we call this internal rationality, we must go back to the solution in the first place. We must go to the nonlinear setup, so that agents are internally rational in the sense that they have beliefs of the aggregate states of and the prices, and they learn, they update their beliefs by observing something that's unknown, that's exogenous to their learning environment. So they still know the solution form, the minimum state variable MSV form, but they simply do not know the model consistent expectation about the full model. So in the sense that in comparison to the Euler learning EL approach, households in this case, they form beliefs about the aggregate variables exogenous to their decisions, and they would still be internally rational because they choose their consumption path optimally by solving for their sort of internal own problem without knowing the whole model as a whole, but with knowing only their own problem. Right.
Sorry, can I just ask, so in Euler learning, in a regular Euler equation, you know what the real interest rate is, so you use that to decide whether to consume more today or not, right? So, and you discount that. So what's going on in E star exactly? So they still do that, is that right?
Opposite point of view said. In the Euler learning approach, we think that this procedure is flawed because it is assumed that the households do not know about the other variables. They only know their next period consumption decision. So they basically make a forecast about their next period consumption decision without knowing the next period interest rate, nominal interest rate. Whereas with internally rational expectation equilibrium, the households, they know the states of the economy exogenous to their microenvironments, which would include future expectations about future interest rates. So they are internally rational because they optimize every single period infinitely about their utility, knowing a forecast of the future exogenous variables about their decision making. So I think this is a crucial difference.
Okay.
And this is the reason why with EL you won't even have to solve the model every single time. You would start with the linearized version, and you would simply replace the expectation term with any learning rules you devise for the model.
Okay.
So there's no optimization taking place with EL, and this is the reason why we think that this approach lacks micro foundation and it may be flawed.
Right.
Okay. But then, in terms of in terms of the beliefs, this may go back to Chetan's question that this can take various forms, and this is where I want to briefly go through next. The terminology difference between IR and the so-called anticipated utility. The two are the same, really. Are the same, really. But they are different in the way how optimization takes place. The IR concept. So this is the reason why perhaps in the subsequent slides I might refer our approach as either IR or AU anticipated utility, or sometimes I refer this as BR bounded rationality. This concept was introduced in an RBC model by Giuseppe and Preston, and Adam Marset applied the concept to finance, to a house. Some people studied housing price model, and Massaro estimated the model, probably being the first author who estimates a behavioral model. and of course, Woodford applied this to an NK model. The IR expectation was also referred as infinite time horizon learning. Exactly the point I was mentioning, that because there's optimality, so households are making optimal solution decisions along the infinite time horizon, individually, if you like, or internally, without knowing the model consistent expectation, but with knowing their own their own beliefs about the aggregate states and prices, which are exogenous to their micro foundations. Of course, there are different terminologies in terms of what one refers as IR as the fully Bayesian optimization, in the sense that both fully Bayesian IR and the so-called anticipated utility framework, which we use in this paper, are very similar in spirit, as I said, but different in details. In both IR AU, agents maximize utility, therefore within the infinite time horizon where learning takes place, where they can all anticipate future utility under uncertainty, given their usual constraints, and given a consistent set of probability beliefs about any payoff relevant variables that are external to their micro environment. So that in the sense that beliefs can take form of a well-defined probability measure over a stochastic process over the infinite time horizon, where people anticipate utility, make optimality at each period within the infinite time horizon with a fully Bayesian optimization. So they incorporate their beliefs with some sort of prior understanding of what might happen in the future. Or alternatively, in our case, we don't go for the fully Bayesian plan, what some authors might call as IR in their papers. What we call IR in our paper would be an AU, in the sense that AU beliefs assume that parameters are not constants when learning takes place, when the agents learn about the parameters, but parameters are become constants, or beliefs are become constants when they formulate decision rules in the current period, when solving for the Euler equation. So basically that's the difference between the so-called IR, fully Bayesian plan, and our AU IR model in this paper. In this paper, we adapt, as I said, we adapt the latter expression, and finally, it has been shown that the two are encouragingly as good approximation between each other in terms of the two learning equilibrium solution.
Yeah. Can I ask something?
Yes, of course, yes.
Yeah. So just to understand the major difference between RE and IR, is it that in IR different agents have different belief as compared to the rational expectation where everyone's belief coincides with the
Precisely.
Precisely that.
Let me just summarize. I hope we could. With RE, first of all, you assume that it's a model consistent solution, so model consistent expectations and perfect information, in the sense that agents know everything. They know the model solutions when forming expectations. They know the whole model and all the states, the minimum states variables, and they have perfect information about all the variables and the shocks when solving the model, when making expectations, when solving the RE solution for the model. Whereas now, IR, what we call our IR, is that agents still know the minimum MSV, the minimum state variable form, but they have beliefs about the aggregate states and prices which are known to themselves. For instance, that's for the households, they would know the necessary variables, the states that are relevant for solving their Euler equation, for solving their utility function, but they must form expectations about the exogenous state of the variable of the model, which are exogenous to their problems, to their decisions. With EL, the difference is that agents would have to know, again, the minimum state variable representation of the model. With EL and IR, they obviously don't know the whole model, don't know the model consistent expectations. With EL, agents or households, they only know their next period consumption decision, which has already been solved for them. And they form expectations about the next period consumption. That's a difference. In the sense that the difference, again, as I said, with EL, agents know they are all the same because they know the next period consumption decision. Whereas with IR, they don't know they are the same because they don't know what they will become next period when solving for the future period consumption decision. There might be for the next period agents, they might become RE, they might adopt RE, they might find RE more attractive, or for next period consumption, they might find RE more costly. So they would have to adopt the other learning rules. Okay, and then finally, for our imperfect information, we adapt the informational consistent principle so that, in a sense, alternatively, we assume that agents are only knowing the same set of variables as an econometrician. So they would have to apply Kalman filter updating when solving for the DSGE model for a solution in the filtering procedure. Does that make
Yeah. Just one last clarification. So while solving, do agents also make belief about the beliefs of other? Or is it that just their own exogenous belief is, in the sense, is enough? Or some consistency is required in the sense that what others may believe and then accordingly I'll just do? Or is it be in the equilibrium, it should hold in a sense implicitly?
I think you're right. I think you're absolutely right. So agents would have to know about
some, okay.
When it comes to when it comes to me explaining the model, maybe this will become clearer.
Yeah, sure. Okay,
perhaps
sure.
we can come back to this because I'm going to go through the model quite briefly.
Yeah.
So yeah.
Thank you.
I think you get the general idea. I think you are getting the general idea anyway.
Yeah,
right.
thank you.
Yeah. Right. So as I said, the third contribution, or perhaps the third contribution is assuming instead of perfect information being extreme, information may be imperfect. So can we sort of, in a way, express learning alternatively in terms of subsets of observables? So if we assume that agents are only able to observe the three variables, GDP, inflation, and the nominal interest rate, as any econometrician would do in the NK model, is that a mechanism in the solution that can attribute learning in that deficiency of assuming the whole state vector. So if there are three shocks, as in the three equation model, and if agents are observing the 3 time series under still RE, so this would be an alternative. So we would either relax RE with learning, or we would stick with RE, but assuming imperfect information, the two competing mechanisms. So agents observing only 3 time series as the econometrician, so can the structural shocks be backed out as a solution, as an infinite, as a var solution, which is used for estimating the DSGE model based on the VAR solution using output, inflation, and interest rate data. This is, again, in other words, this is saying whether the VAR solution is existent for the DSGE model. Or in other words, that if we have 3 shocks and 3 observables, whether the DSGE model is invertible. So the problem is that even though there are 3 shocks and 3 observed variables, there may be a non-trivial invertibility problem that may not be violated, so that there is no transformation between DSGE model to a VAR solution. So in the sense that one cannot interpret the DSGE shocks as the structural shocks if the VAR solution may not be invertible or existent. Especially in our example, when we have a number of shocks, because we have 4 shocks in our model, there being the monetary policy shock, the markup shock, the technological shock, and also I think a stochastic productivity shock. So there are more shocks than the number of observables, because potentially we only use, on purpose, we only use 3 observed variables in our estimation. Then the so-called invertibility condition must break down. Then one has to think about the imperfect information RE solution. That's just another incentive why imperfect information may be a more plausible assumption for DSGE model solutions. Right, so as I said, because in endogenous persistence, because endogenous persistence is in the title, because we want to emphasize the point that by the KF Kalman filter learning, the model generates some endogenous persistence without relying on habit formation, inflation, inertial. This model underlying persistent mechanism. So keeping the model, while keeping the model as parsimonious as possible, is there endogenous persistent mechanism that can be introduced by simply assuming agents have imperfect information. Okay. So right, back to the question, perhaps. In constructing the IR equilibrium, the IR expectation equilibrium, we have to solve the households. How am I doing with time? Oh, I only got 15 minutes. So we've got to solve the usual household budget constraint forward in time and impose the transversality condition on debt. And the procedure, we then use the usual first order condition, but we either linearize for the model because of the EL, which only needs a linearized solution, or instead of assuming RE, we assume some form of point expectations for the consumption decision as a function of the adaptive expectation of interest rates, wages, and profits. For the firms, the supply side, we solve the Calvo contract as usual for the price optimization firm as a function of, again, either linearizing the model for the EL or the standard RE model or the EL model, or instead of RE, we assume point expectations for the demand side variables. Then the model is aggregated, again, crucially, for the IR without agents knowing that they are the same. However, on the other hand, the EL simply assumes that, in effect, that the linearized model is the underlying economy. So the linearized solution represents the DGP, so that one simply mechanically replaces RE with an EL form of expectation. Right? So as I said, our model of learning is where agents are rational. In the sense they are rational, but they are internally rational, because they are rational regarding their internal decisions about solving for the consumption with respect to the variables, the aggregate variables that are exogenous to their decision making. So quite briefly, we solve for the usual household budget constraint forward in time, and combining with this with the usual first order condition of the utility with respect to with respect to hours, which gives us the labor supply rule, and we present everything in present value terms, which will give us the following form, where this would be the PV of the future consumption decisions for the jth households, and this would be the present value of the labor supply decisions of all the future values for the jth households, and gamma t represents profits. Then we need a solution instead of RE to the household decision function for the consumption decision of non-rational point estimation of the following forms for the wages, for the interest rates, and for profits in the Euler equation, as opposed to rational model consistent expectations, whereas the point expectations will take form of the as in its simplest form, adaptive expectation for one period. Whereas in the general form, then this would be adaptive for all future periods. So using the Euler first order condition, our internal rationality solution would give us the Euler equation again, and the labor supply function, which constitutes the consumption and hours decision rules, given the point expectation solutions for our model, for the Euler equation and the labor supply rules. Again, the more details will be in the paper and in appendix, and I presume that the paper of which has been circulated to the audience. Really the difference is that in this case, E star replaces the usual RE, which is now the alternative solution. For the IR solution of the firm side, again, this bar is quite annoying. Follows similarly. So really, I want to take some minutes to re-emphasize why we think the EL approach is flawed, because this contracts the mechanical approach of EL, which basically just substitutes substitutes the adaptive expectation of utility for the rational expectation about the utility of consumption. Because if we think about the solution of nonlinear DSGE models, any nonlinear, or perhaps our rational expectation RE solved nonlinear DSGE model can typically take the following form. So with rational expectations, where yt plus 1, yt minus 1 are the endogenous variables in their predetermined form, in their forward-looking form, and in their static form, where epsilon are the exogenous shock or the shock processes. The first step is always linearizing about a deterministic steady state, which will give us the following general form about the linearization, where this is the measurement equation, where which is linking a set of observables to the endogenous variables. Then solving for the linearized model, solving for the system with the standard RE algorithm of scenes, for instance, 2002, this will return us a solution if invertible. If the invertibility condition is satisfied, this will return us a solution in the form of a first order VR based on the so-called minimum state variable solution for the DSGE model. So that the endogenous variables, this is also regarded as the decision rule, right? Because the endogenous variables is based on the lagged term of the endogenous variable, where this is the matrix of the theta model parameters, and also yt is a function of the zt, which is the exogenous process for the structural shocks. and this is the measurement equation. The problem here is that simply because this starts out with the linearized model, this is assuming that the linearized model is the underlying model for our economy. The problem is that when the underlying model may be nonlinear, especially in our case when we talk about the incorporating expectations into the model might become highly nonlinear. Then agents really, when observing, say, policy changes, they really need to take into consideration the nonlinear nature of the system. Really, this will have implications for the solution based on approximation and the decision rules. So this is where, for the EL approach, it starts out with the linearized model by simply replacing E with the EL expectation without considering the nonlinear nature of the economy. Okay, so this is why we think EL is flawed. When coming to the firm side, I'm going to go through this quite quickly because this is really standard. This is just a Calvo, the standard Calvo economy, where there's a probability of 1 minus xi each period of the firms or the retailers who can optimize so that they can set the price to PO, the optimized price level for the nth firm. So upside would measure either the probability or the stickiness of the ability of firms changing their prices, the contract length. If the price is not re-optimized, then it is being held fixed to the previous period prices. Then for each M, given the marginal cost, its objective is to maximize its lifetime profits into the future, where this is the discount factor, the stochastic discount factor, and this is the output into the future. And inside the brackets, this will give you the profits, right? Output multiplied by the optimized price minus the costs where the price cannot be optimized. We would be fixed for the K period into the future. So the firm's objective is to solve where MC is marginal cost and MS is the markup, depending on the competitiveness of the market. And this the objective is maximized for the firm, for the M firm, subject to its usual supply function. Yeah. So the solution, again, the details of the solutions are in the appendix of the firm or of the paper. So this will give you the usual Phillips curve solution, assuming that the aggregate price is the weighted average between the previous period price and the optimized price. That this gives the price index for the aggregate economy for the Phillips curve. Then we would have the standard New Keynesian Phillips curve. But the difference here is that if we replace, again, within the solution, in the nonlinear form of the model, if we replace all the RE with the point expectation formations, and this will give you the nonlinear Phillips curve in the point estimation form, where we will have point estimation expectations about inflation, output, marginal cost, which is a combination of marginal cost and markup, and the real rate, which is the return to investment. Okay, so perhaps no time to go through too much on the detail of the model, but as I said, more can be seen from the paper and the appendix. So to sum up, to summarize the modeling, we consider two groups of households. One may be RE of the factor prices and profits, and the other may be IR. Similarly, two groups of firms One group may be RE of aggregate consumption, marginal costs, and real interest rates, and the other R would have to be IR using point expectations. And the final part of the model deals with this survey evidence that people observe that consumers may be distributed across those with some being rational and some may be adaptive. And the proportions of being rational and or adaptive may evolve over time in response to some sort of a measure of forecast error, some sort of attractiveness measure. And this is the reason why, as I mentioned before, we have this last feature in the model, which will impose enforcement learning to rule out any stupid behavior, to rule out any incentive of switching between RE and adaptive. Sorry, to incorporate any incentive from switching between RE and adaptive and vice versa, using a discounted least square estimator, which is the sum of past weighted forecast errors as a measure of fitness, as a measure of attractiveness, as a measure of a random choice between RE and IR. So this will give us the final set of model, the composite, which we'll call the later on either IR RE composite or a BR, a bounded rationality composite equilibrium, where the IR households make rational, sorry, the IR households, they are still rational, but they are only internally rational because they make a rational intertemporal decision of their own consumption and their own labor supply, given their AE, adaptive expectation, of the future. This might address your previous question. Given the adaptive beliefs of the variables that are necessary for solving their decision function, but are exogenous to their micro decision environment, to their problems. Precisely, they take our AE of wage, nominal rate, inflation, profits, which are all exogenous to the agents at time t when solving for their intertemporal function, utility internally rationally. Whereas the IR firms, still rational, but internally rational, they set their PO, the optimized price, given those variables that are exogenous to them at time t. And this AE of these variables may be observed with or without a period lag, so that one might assume that expectations may be made with a period lagged effect, right?
So
sorry, yeah.
just one clarification. So the point I asked previously, so here then the belief of an agent does not require to know or form belief about what others are believing. It's just that this agent has some belief and then do according to AE, it will choose rationally.
Exactly.
Right?
Exactly.
Okay.
That's right. Yeah, exactly. So they don't know the others. They don't know that they are identical. They don't know whether they are the same agents or not. They only know themselves. So
and
they
plus,
don't know their other decisions. They can
according to your modeling, they even don't need to know also, right? They don't know, that's obvious,
they don't
but
know, they can learn about the others' behaviors. They can learn about the others' mistakes. They can learn about the others' focus areas. But they do need to know if we want to keep the model entirely endogenous, which I will mention in a minute. But in terms of solving for the solutions, they do not know, but they can learn via the enforcement learning in a minute. So they don't know each other. They don't know whether they are RE or IR. They don't know about whether they will become RE or IR in the future. And they don't know about the other agents, whether they will be RE or IR in the present time or in the future. They don't need to know, but they can learn. They don't need to know those for solving for the model, but they might choose to learn in order to switch between RE and IR into the future.
For their own better decisions, they might want to learn.
Yeah.
No, thank you.
Yeah. Yeah. So yeah, precisely, the IR do not need to know whether they are identical in equilibrium, and this is crucially the difference in the solution procedure. But now the last point to come to is the forecast rule, and this is really just the standard adaptive expectation formula, where a lambda measures the speed of learning. If lambda is 0, then there's no learning. Adaptive expectation becomes the previous realized value. If lambda is 1, the other extreme means the fastest learning, then the adaptive expectation will become the previous periods, the difference between the actual value in the previous period and the expected variable. And of course, X stands for the real wage inflation nominal rate for the households, and inflation, producers' inflation, marginal cost markup for the firms when solving for PO. Reinforcement learning, really now, how do we believe whether RE and IR, whether they can know each other, whether they can learn each other, and whether they can switch between RE and IR, or at any given point in time, what may be their proportion of households that are RE and or IR. So we want to work out a probability, right? The probabilities of being RE, the probability of the proportional of firms and households that are rational at any given point in time, where the probability can be modeled by a logit, a function which is ensuring that the probability is bounded between 0 and 1. Where the psi RE for Z, which is either household or firm, the psi would be the attractiveness measure. The measures the payoff of being RE. It measures the forecast performance of the RE and non-RE predictor of the outcome, which are given by the following least square discounted least square forecaster measure. Right. Basically, this says that the larger the weighted sum of all future forecast errors, and the larger of any given fixed cost of being rational, the less, because of minus sign, the less attractive of being RE. So smaller the probability of being rational rational agents at T, right? As simple as that. Where gamma is what they call the intensive of choice parameter, which determines the switching sensitivity between RE and IR, based on the performance of in terms of the forecast error. Really, if gamma is close to 0, then then it doesn't matter switching between RE and IR, and if gamma tends to infinity, then the forecast performance of RE as a measure of attractive becomes infinitely important. In our exercise, we assume as a standard in the literature, gamma is the standardized, normalized to be just 1, so a moderate intensity of choice parameter. So this really completes the model, everything. Were there any questions in terms of the models so far? Sorry,
I just want to, we are basically, it's about an hour, so we have about 10 minutes for anyone to ask questions, if you're done with the presentation.
Can I just have 5 more minutes to go through the results?
Yes, go ahead.
So a bit of a simulation really here. First, before estimation, is that I'm not going to go through this for too long. If I compare the 3 models, RE-PR, RE imperfect information, and our bounded rationality model, for the 2 learning speeds, 0.25 being slow learning. I think this maybe I think it's 0.5, not rather than 1. So 0.5 being fast learning, with the Taylor rule of the standard parameter calibration for monetary policy. So they all have the same signs, luckily, right? positive interest rates reduce output, consumption, employment, real wage, and also inflation. The point really I want to make here is that it really seems, based on the standard calibration of the Taylor and the remaining model, the only difference between the models are the two speeds of learning. It seems that with fast learning, this generates more persistence, more hump-shaped response. So it takes really longer for the economy to go back to its steady state if there is learning that's taking place, with slow learning, right? So the longer the learning takes place, the more persistent that this generates to the model, precisely generating what we call as endogenous persistence in the model without resorting to any mechanical persistence formations. So that's the calibration. Fairly quickly with the estimation. Right, Bayesian estimation. We estimate, let's just, for the sake of slides, we estimate three models: RE, the pure IR, and the composite. Assuming that the proportions are fixed. Go back to endogeneity problem, the full Brock-Hulmes models, which have has the endogenous fractions. This would require nonlinear estimation, which would become extremely difficult, especially for the imperfect information solution, because nonlinear methods would have to be required to pin down the parameters in the steady state, the n's, the lambdas, and the reinforcement learning parameters. The empirical model is entirely standard. Growth is incorporated into the model. Inflation is consistent with the calibration of the data. How many shocks? 1, 2, 3, 4 shocks. 2 AR technology shocks, 1 markup, 1 government spending shock. Sorry, more than 1, 2, 3, 4, 5 shocks, right? And there's a stochastic trend shock for the technology and also monetary policy shock. Assuming that learning is uniform across all agents for the firms and for the households, for simplicity, of course. We obviously discussed about different learning parameters, and this did not change the results. The data is for the moderation period, the great moderation period. For the US, 3 observables to ensure that the imperfect information solution will make a difference, will have an impact on the economy. So we assume that there are more number of shocks than the number of observables, so that agents can learn also about the shocks by Kalman filter learning. Giving fixed proportions, so we don't estimate them, they assume to be 0.5 and 0.1. If this is 0, then we would have the perfect pure IR model. And if this is equal to 1, the model converges to the pure RE model. Fairly quickly, what's this title? Oh, right, so this is the IR estimation, the II estimation, imperfect information. Now assuming that information is consistent, while still staying with RE. Same model, same data as before, apart from assuming that information set is now the same for the agents and the same for the econometrician. Where we assume that to keep everything consistent, we assume that the expectations about output from the firm side, inflation from the household side, are all taking with 1 lag. So we assume that the observed variables are also with a lag. This is consistent with the reality, in which it's assumed that the publications of output and inflation data are often with some lags, whereas the one tends to assume that nominal interest rate is observed without contemporaneously. So same consistent information set for the agents, for the solution, and for the econometricians for estimating the model. So really, the main results, fairly quickly, the first thing that's highlighting the results is that it seems that in terms of the likelihood comparison, the pure RE with imperfect information gives the highest probability for our model given the data via the Bayesian comparison, whereas the standard RE perfect information, the most extreme assumption, seems to be underperformed in our model comparison. Another thing is in terms of the stickiness parameter in the Calvo economy. It seems that with some learning, you relies less on the Calvo stickiness, nominal rigidity, nominal friction in the model, in the sense that this is much lower, so the contract length is much lower, so there's less persistence needed to be modeled by the Calvo contract, right? If there's a learning. Learning is found to be quite significant, quite fast, 0.91 in our model, suggested by the data. Another crucial thing is that this makes huge implication difference in terms of the policy design, right? Because for the inflation feedback, the policy rule becomes much less active. So inflation feedback is a lot lower. This is suggesting that this has stability analysis implication, right? Unless the policy rule is specially designed for IR, uncertainty as to which model of expectation is correct will have implications on the stability and the indeterminacy of the problem. So one needs to carefully design policy rule, because this, with learning in our model, this really restricts the parameter space for policy setting. You might also find that the persistence of technological shock is now much higher. So you might suspect that if there's any persistence that generated by this model, this may be a reason of rho A. So as a result, in the appendix of the paper, we basically shut down all the persistent parameters for the shocks, and we would still find some level of persistence generated by either between the IR model or the imperfect information setting, where the both model rely less on the Calvo nominal frictions. And remember, this is the most parsimonious canonical NK model without any habits and any other underlying persistent mechanism. I'm going to skip this. I'm just going to jump directly to the conclusion, really. But basically, the validation sections shows that both IR and RE are able to match the data well, as opposed to the traditional RE model. Whereas there's evidence of generating persistence, and for the heuristic composite model, there's evidence of matching well with the sample autocorrelations. So basically, I mean, despite being a quite preliminary forms, and the results might be questionable in terms of, this is the reason why I did not present the impulse responses, which we had in the paper, really, because there are questions with the problems with impulse responses, really. But the main message here is that it's of course in the modeling contributions that I presented before, and in the empirical section of the model, we ask whether RE with non-standard IR as plausible as a candidate learning model, as a now well-established composite BR learning model, IR learning model. We think that EL is flawed. So we think that EL provides inadequate micro foundation for the precise reason I mentioned before. We think IR is more consistent with the reality, and makes less informational demands than EL, because the agents do not need to know they're identical. They only need to focus on optimizing their internal decision at time t about their future consumption decisions. Estimations suggest that both IR and II model, imperfect information model, fit the data far better than the standards extremely assumed RE case. And as I said, there have been some empirical exercises to validate the model and to show how second moments may be matched well from the hybrids BR, IR. Sorry, I'm about the mixture of notations. hybrid IR or BR model with RE and IR. That's the point is that they, with the parsimonious formation of the simple model, really by incorporating both BR and IR, we can show evidence of additional or alternative source of learning, either via the learning rule or via the common filter techniques, which can perhaps capture the persistent mechanism we observe in the real world. So that hopefully has summarized the conclusions and contributions. That's it. Thank you.
Thanks for a great talk. And thanks for all the participants. I think we have maybe about 3 or 4 minutes for questions.
Sorry about this. My apologies.
So, Bo, quick question. So, if you didn't estimate this over the Great Moderation period,
yeah.
If you took a say 20-year time span before 1984, or did this from let's say 2009 onwards, presumably you would get similar results. Would you want to validate the model over periods not where you had low stable inflation, but where inflation was higher? And it's number one. I'm not sure whether you did that. And the second thing is the endogenous persistence coming. So your Taylor principle gets it. I mean, still above 1, but it's lower, and the Calvo parameter becomes lower. Is that right? So you get lower parameters in the IR framework,
yeah.
and then that has implications for effectiveness of monetary policy and so on, because stickiness changes and so on. So is that the reason why the endogenous persistence is coming in? Is that the structural parameters are also now changing partly? Is that?
Precisely.
Yeah.
I mean, if we look at this table, this is probably one of the 2 highlights that I want to mention. As you said, the policy space has been significantly different with the IR assumption. So the policy feedback is much lower. The reason for this is that it assumes that if agents learn about the inflation, if they learn about past inflation adaptively at each period, so they basically the inflation mechanism is really catching up with reality in each period. So this requires policy making to be less targeting hawkish, yes, to be less hawkish in terms of inflation, because they will expect that the agents will learn very quickly. Another reason for the chi, of course, is that because they learn about their wages, so they know that their real wages will become constantly lower than expectations because they form adaptive expectations with quite fast learning rules. Then they would negotiate for their price contracts or wage contracts more frequently than usual, because they want to keep up with the real inflation, with the inflation of the real price of the economy. So this again suggests that the model suggests much more frequent price changing and hopefully more wage changing, or much shorter contract length. So the contract length underlying to the economy, inherent to the model, by estimation becomes much lower. So suggesting less, suggesting more persistence.
Well, it suggests that you're closer to the flexible price allocation, right? So that means, I mean,
that any persistence generated must be coming from the learning rather than coming from the contract length, other than coming from the stickiness of the economy, right?
Except if your contract length is getting smaller, then monetary policy is less effective, right? So you would think from that sense, there's less persistence because you don't have longer contract lengths. But on the other hand, here you do seem to be getting persistence because of the learning. Is that right?
I think that's the point we really want to make.
Yeah.
Perhaps I didn't make it clear.
Yeah.
The monetary policy is less effective because of the more flexibility of in the model. So money becomes more neutral in the economy. Then the model implies a lot less persistence.
Yes, right.
In model solution, whereas in estimation we still see even greater persistence.
Right.
So that has to be it has to be due to the learning procedure. There's no other way of explaining this, right?
Right.
So that really is exactly the whole point we're trying to make.
Yeah, that's interesting. Yes.
So it relies a lot less on the nominal rigidity of the economy and relies less on the smoothing parameter. So the monetary policy rule is now even less persistent.
Right.
So, and your first question was yes. Precisely we will be hoping, because it's always the easiest to deal with the great moderation periods. But we'll be hoping that we'll extend the model into the data in the past, because this is where especially in the 1970s, this is where the Friedman's expectation hypothesis, or Lucas, became validated in expecting the economy to be catching up with reality expectations. So you'd expect that the results to be robust by extending the sample size into the data in the past, but also into the post-zero lower bound periods, which will also be using the shadow rates, the Wu and the Xia proposed shadow rates, which can mimic the nominal interest rate when the actual rates are lower than zero.
Yeah.
Sorry, the actual rates are staying at zero, whereas the shadow rates can be below zero. So we'd expect that extending the samples to both sides would give us the similar sort of conclusions. So far, we've not been able to find that yet. This is the reason why the paper is hanging around for a long while without getting finalized answers to our solutions.
Right.
Yeah, but you're right. Yeah. It would definitely be the missing part of the solution, the results.
Okay, I guess we are out of time. So thanks once again, Bo, for a great talk, and thank you to the participants once again. See you all next week.
Yeah. Thanks, Bo.